All right, this is a part two of a skill set video lesson about simplifying rational expressions. Just as a reminder here, we're not trying to solve, we're not trying to find the value that makes anything true. These aren't even equations. We're just trying to take something that's complicated and make it easier and more simple to work with and to look at. As we discussed in earlier lessons, the goal is to look for common factors in the numerator and in the denominator. That way we can actually divide out common factors and get something that's much simpler. So a divided by a is 1. 5 bigger than a divided by 5 bigger than a is also 1, and we're left with 2 divided by 3. This is actually kind of a cool result because you can see the final simplified result is 2/3, and it doesn't depend on the value of a. I can let a be anything I want, and I will always get 2/3 as a result. That's what the math is saying. For example, if I let a equal 7, it would be 2 times 7 times 7 plus 5, which is 2 times 7 plus 12, over 3 times 7 plus 12. The 7s would divide out, the 12s would divide out, and we'd be left with 2/3. If you don't believe me, try it yourself. Pop in 7 for a, do all the calculations, do some long simplification, and you end up with 2/3. It works. But today, I would also like to talk to you about the concept of domain restrictions. And so basically, there's one thing that we have to worry about when dealing with rational expressions and later rational functions. There are some instances where the choice of variable might make it so that the denominator is equal to 0. And we know that we cannot divide by 0, so basically we have to figure out how we're going to deal with this. So, first thing I want to point out is the end result, as we said, was 2/3 every time. So I'm just going to put this result into Desmos just to see. And what we can see is I have the original given expression. I used x instead of a. And here we can see the y values are all the same. And if I click the line itself, you can see that all of the different y values are 2/3. That's 0.667. Until I get to 5, look what happens at 5. There's an open circle at -5, and it says that the function or the expression is undefined, because when x is equal to -5, the denominator ends up being 0, and you cannot divide by 0. So even though every single y value is 2/3, -5 is excluded because you couldn't use -5 in the original expression. The other exclusion you will find over here at 0. So how do you find those restricted values? The answer is really simple. All you have to do is set the denominator equal to 0. Whatever the denominator is 0, that's when you have a restricted value. So I'm going to take this denominator right here and set it equal to 0 and solve. I'm going to use the zero product rule. A is 0, that's one of my restrictions, or if a was -5, that would give me another restriction. So I include those restrictions at the end. When I say that this simplifies, I will say it simplifies and a cannot be 0 or -5. Okay, so looking at the next exercise, same concept. The only difference is I'm being asked to multiply these fractions. And recall that if you multiplied 2/5 times 3/8, that what we're doing really is we're finding out how many total denominators we have. We're going to divide up into 40, and then we multiply across 2 times 3, and we get 6 over 40. Or even better yet, you could divide 2 into 8 and get 4, and then you multiply across and you get 3 over 20, which is the reduced form of 6 over 40. Well, the same thing can happen right here. For example, I could choose to divide out the common factors, just like I divided out the 2 from the 8 over here. I could also divide out these common factors, and then I can just multiply the numerators across, just like I did with regular fractions. The other approach, which is, in this case, since we're learners, is worthwhile, is to just show the multiplication of fractions without doing any extra busy work. I put down my domain restriction right away, sorry. And right here I can show that I just took the 3, the x minus 6, and the x plus 3 and multiplied them all together for the numerator. I took the 4, the 3, and the x plus 3 and multiplied them all together for the denominator. And then I divided out common factors, x plus 3, I think there should be a plus sign there. And 3 divided by 3 is also 1, leaving us with x minus 6 over 4, and x cannot equal negative 3. That's my restriction. As you can see, when I check with Desmos, I get a linear function. Even though this does not look linear at all, it does simplify into a linear where the slope is 1/4 and the y-intercept is negative 3/2. Now, before I go through the last exercise, I wanted to share one last thing, and that is, how do we use the graphing calculator to check our work? You will not have Desmos on your any assessments, but you will have access to the graphing calculator on many assessments. So what to do? To answer that question, I first want to remind you that you can store in every letter of the alphabet a specific value. So instead of letting x be any number, I'm going to let x in this case be 3. I like to pick a small prime number. So to do that, I just pick 3, and then I hit the stow button right there, and then I hit the X button, and then I hit enter. Once it says done, or it'll say x equals 3, or it just says 3, so I'm done now. Now I'm going to type in the original expression as it was given to me, which if you see here, it's going to be, yeah, you know what it is. I'm not going to show you the whole thing. It's all there, but when I hit enter, it tells me that when x is 3, the expression that I was given is equal to negative 3/4. Now I'm going to just give me a second, sorry. I'm going to pull up x minus 6 over 4, which again, that was the expression that we were simplified to. And when x equals 3, we get the same result. So this is how you verify. You type in the expression as given with the right use of parentheses, allowing x to be a specific value, and then you put in your simplified result and see if you get the same thing. You could also do this in function mode and just look at the tables. Please make sure that you spend the time to check your answers rather than looking at the back of the book. Last issue to address, and I'm not going to talk about checking answers or anything, I just want to talk about division of fractions. Here we are asked to divide, not multiply these fractions. Before I do, I'm going to acknowledge my domain restrictions. Any denominators that equal 0 give me restrictions in the domain. So x cannot equal negative 2, nor could x be equal to negative 1. Or 1, sorry. Now, for the division algorithm, I just wanted to remind you again what we do with fractions. Back in grade school, they said in order to divide by a fraction, you multiply by the reciprocal of the second fraction. I did that for years without ever questioning it. Why? Why multiply by the reciprocal instead of dividing by the fraction? The way I look at it in algebra, we divide using this vertical alignment. So 2/3 divided by 5/8. And what I'm going to do is multiply the bottom, the denominator, by 8/5 so that I get 1 in the denominator, but you multiply top and bottom by 8/5, and now you can see that instead of dividing by 5/8, I'm effectively just multiplying by 8/5. So why do we multiply by the reciprocal? Because that gives you a 1 denominator and enables you to multiply instead of divide. So in general terms, if I have a divided by b over c divided by d, it's really a divided by b times d divided by c. In other words, and this is the way I always visualize it, these two multiply and then those two multiply. That's how a little shortcut in my brain. Anyway, the same thing can be said for algebraic expressions. Whether this is a 2, a 3, an n minus 3, an n plus 2, they're all unknown quantities. So I'm just going to show the multiplication. So as you can see here, I took the reciprocal of the second fraction because n minus 1 squared is n minus 1 times n minus 1. And then n minus 1 times n plus 3 now became the denominator. And this is supposed to be plus 3. All right, so now I'm going to multiply the fractions together, divide out all common factors, and state my restrictions. Again, I've showed you two ways. There's the Desmos way, there's the graphing calculator way. There's also just manually putting in a number for n and seeing if the original expression matches the n down here. But I've already talked about that. I don't want to take up any more time on this video. But follow those basic directions in the homework exercises. I lifted some from the internet that's going to show, there we go. Some simplifying like we did yesterday, and then we get into some division and multiplication and everything else. And so just work through these plus the ones we were supposed to do for yesterday. You got a couple days to get this done. Thanks a lot and have a great day.